Today we're going to be looking at Learning Target 23. I can show decimal expansion for rational numbers. We know that rational numbers are numbers that can be written in fraction form. However, when they are in decimal, we can recognize them as either decimals that terminate, as we looked at in our previous lesson, or decimals that repeat. And so today we're going to look at how do we convert repeating decimals to fractions. Now, this is only the shortcut way. There definitely is a longer process that explains why this works. But for the sake of time, we are going to show the shortcut way. So this is part A. This is when all digits repeat. So if every single digit repeats, the denominator is going to use some form of 9. So if you have one digit repeating, such as 0.7 repeating, so 0.77777, so on and so on, you would have 1 9 in the denominator, so 7 over 9. If I had two digits repeating, something like 0.36363636, that would be over 2 nines, so 36 over 99. And then, of course, we would want to reduce that. So I know that those are both divisible by 3. So that would give me 12 over 33. If I had three digits repeating, so something like let's go 222. Nope, that would be the same as one digit repeating. So let's be a little more creative than that. 212. So 0.212, 212, 212, 212. That would be over 3 nines. So I'll write that over here, 212 over 999. Okay, and then that should be divisible. 212, is that divisible by 3? 2 plus 1 is 3 plus 2 is 5. It's not. Okay, so we could leave that as 212 over 999. And then as you can recognize from the pattern, if we have four digits repeating, so 4.4132, 4132, 4132, 4132, that would be 4,132 over 9,999. And let's see, 3, 5, 6, 10. 10 is not divisible by 3, so that should be in simplest form. So to practice, if I have 0.6 repeating, so 0.66666, so on and so on, it would be 6 over 9. Now that is simplifiable. I can divide by 3, and that gives me 2/3. So my simplified fraction for 0.6 repeating is 2/3. Now 0.9 repeating, 0.9999999. This is what we would call a special case because according to our rules, I would do 9 over 9. But we already know that when I have a numerator and denominator that are the exact same, that simplifies to 1. So this is a special case because the decimal 0.999 repeating, so on and so on, is so close to 1 that we essentially say it is 1. And that's where it's a special case. It's definitely a little different, that a decimal could equal a whole number, but it's more because it's essentially the same thing because they're, 0.999 repeating forever is basically the last point before you get to that whole number. All right, we have 0.12 repeating, so 1, 2, 1, 2, 1, 2, 1, 2. So I would do 12 over 99. And then I can reduce that. 12 is divisible by 3. So that would be 4 over 33. And then 6.123123123123. Okay, so that whole number, I'm just going to pull that out in front. And then I have 123 over 900 over 999. Okay, and I don't believe, let's see. Oh, 1 plus 2 is 3. 3 plus 3 is 6. So that is divisible by 3 because I can divide by 6. So if I divide by 3, that would give me 41 over 333. So the final answer would be 6, that whole number, and 41 over 333.